Hello all, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In July 2024 lecture series, we are discussing about virtual reality modeling techniques. In this, we have geometric modeling, kinematics modeling, physical modeling, and behavior modeling. Okay, how do we manage these models? With the help of model management techniques, we can manage the VR modeling techniques. Okay, first in this model management part 1, we are going to discuss about how do we manage the modeling in virtual reality environment, and we'll discuss about some examples in virtual reality environment. Okay, why do we need this model management? Actually, it is necessary to maintain interactivity and constant frame rates when rendering complex models. Here we have so much of techniques. The first one is a level of detail segmentation, and second one is cell segmentation, third one is offline computations, and fourth one is lightening and bump mapping at rendering stage, and the last one is portals. Okay, here in this level of detail segmentation, LOD, it relates to the number of polygons on the object surface. Even if the object has high complexity, its detail may not be visible if the object is too far from the virtual camera. Here, virtual camera is our observer. See here, see here, a tree in virtual environment, a tree with 27,000 polygons. See here. And see here, tree with 27,000 polygons. Here the details are not perceived. See the differences. So we need the detail segmentation for perfect clarity. Okay, second one is static level of details management, when we should use a simplified version of the object using fewer polygons. When it is far from the camera, there are several approaches. We have discrete geometry LOD, alpha LOD, and geometric morphing. It is called geomorph LOD. And for discrete geometry LOD, it uses several discrete models of the same virtual object. Here the models are switched based on their distance from the camera. If the distance is longer means we have less number of polygons, so the clarity is reduced. So we have to reduce this. So we need to improvise the number of polygons in the tree. Example, we use tree. We have to improvise the number of polygons in the image or object, so we can get the better quality. See here, R less than R0, R0 less than R1, and R1 less than R2, and R2 less than R. See here, see the clarity. See the clarity difference between LOD 0 to 2. LOD 0, here we have high clarity and we have high number of polygons. And LOD 1, the clarity is reduced, same, the polygons numbers are reduced. And LOD 2, same, clarity missed, as well as we have less number of polygons. Here we differentiate LOD 0, 1, 2 with distance R0, R1 and R2. Okay, our main goal is to improvise the clarity of the observer. So only it provides a real feeling in the virtual world. Okay, what is this alpha blending LOD? Discrete LOD have problems on the R0 equal to R, R1 equal to R, and R2 equal to R circles, leading to popping. Objects appear and disappear suddenly. One solution is distance. Here the another solution is model of blending. Two models are rendered near the circles. Here another solution to popping is alpha blending by changing the transparency of the object. Fully transparent objects are not rendered here. See here, opaque, less opaque, and fully transparent regions. Here we have LOD 0, 1, 2 with distance R0, R1 and R2. And to improvise the clarity, we go with geometric morphing LOD in higher level. Unlike geometric LOD, which uses several models of the same object, Geometric morphing uses only one complex model. Various LOD are obtained from the base model through mesh simplification. A triangulated polygon mesh n vertices has 2n faces and 3n edges. See mesh before simplification, mesh after simplification. Before simplification, we have collapsing edges which may reduce the clarity. And mesh after simplification, it provides a perfect image in the VR environment. Okay, a single object adaptive level of detail LOD, it is used and where there is a single highly complex object that the user wants to inspect, such as an interactive scientific visualization. A static LOD will not work since detail is lost where needed. Example, the sphere on the right loses shadow, sharpens after LOD simplification. See here, the sphere with 8192 triangles, uniform high density. See here the second one, sphere with 512 triangles, static LOD simplification. See the difference, see the clarity. Okay, here sometimes edge collapses leads to problems, so vertices need to split again to regain detail where needed. Here Zia et al. In 1997, they developed an adaptive algorithm that determines the level of detail based on the distance to viewer as well as for normal direction, lightening. See here the refined mesh and simplified mesh. Here the vertices V1 and V2 vertex split, and here edge collapse is avoided, and V1 is the parent vertex. Finally, at last, we have the refined mesh with high clarity object view. See here, single object adaptive level of detail example, sphere with 8192 triangles, uniform high density and 0.115 second to render. See here, the second one is sphere with 537 triangles, adaptive LOD 0.024 second to render. See here, see the clarity. Which one is better? Which suits for VR environment? See the second one, bunny with 69451 triangles, uniform high density with 0.420 second to render. See the second one, bunny with 3615 triangles, adaptive LOD 0.110 second to render. See the difference. Which one has high clarity? Which suits for virtual reality environment? Actually, to provide more triangles or more polygons, which provides high sight on observer side, which gives a high clarity output in the user side. So we prefer as much as triangles and polygons to provide a better feedback in the user side. Okay, what is the static LOD? Geometric LOD, alpha blending and morphing have problems maintaining a constant frame rate. This happens when new complex objects appear suddenly in the scene. So, see here, frame I and frame I plus 1. Here we have LOD 1 and 2, and here we have camera flyby. And also, if a sudden scene is entered means this geometric LOD, alpha blending and morphing have some problems in it. So we have to reduce it. See here the architectural walkthrough. See the camera path through the auditorium, start, end. And also we have to define the frames as well as the time. Here we have no LOD management and static LOD management. See here, see the polygons. No LOD and static LOD management. See here, with the help of LOD management, we can fix the problems in virtual world. By using this geometric LOD, alpha blending and morphing techniques, we have some problems in sudden scene entering. So we have to fix the problems with the help of LOD management. With the help of this LOD management at the user side, from virtual reality environment user side, we can control that LOD. We can control that interrupt with the help of LOD management. Also, we will give a better experience in virtual world with the help of this LOD management. So we go with model management techniques in virtual reality. That's it. Thank you.